If you weren't in my last talk, my name is Tome. Tonuff, T-O-E-N-U-F-F. I didn't actually put my information on this particular deck. This is a Prezi. This will be available after. Tonuff is the Twitter. I live in New York. I work for a major financial downtown. I also run the New York City PowerShell user group, and we have a yearly Techstravaganza that happens that's very similar to this, but one track instead of these awesome 3 tracks. Anyway, so that's who I am. And what I'm here to do today is talk to you a little bit about parallel execution in PowerShell. So how you make things faster. That's what this whole thing is about. And I imagine that's what you want to get out of it. So if you don't, if you want to make your script slower, you can leave to leave right now. So let's talk about, first of all, this is an interview question I give all the time. Okay, and it's not designed to actually have an answer, although every time I say this to a friend, somebody who's actually really good, they generally think that there's only one answer, and then they start to think about it, and they're like, oh, there's a couple of ways we can do this. But basically, it goes like this. It's you've got this great script, it's working perfectly, it's hitting a massive amount of computers. It's just taking 6 hours, and 6 hours is too long. Is there anything we can do to speed that up? How would you approach that problem? And there's 2 ways that you can look at this problem. It comes down to everything both sides of it are all about concurrency. It's all about running it multiple times or running it in parallel. I mean, that's what this talk is about. On the left-hand side here, we've got distributed computing, parallel computing, and concurrent computing, which are all synonyms, actually. I think there may have been a distinction at one point in comp sci, but that's changed over time. And actually, they're all acceptable as sort of one thing now. But that's all about multiple computers. So that's leverage the computers that exist out there. So if you're hitting 45,000 desktops, maybe those 45,000 desktops are the ones that should be running the script, and you just collect the data. Okay, so that's concurrency. That's getting the script to run multiple times. You can also think about having like multiple servers running this stuff, so you could actually distribute it to like 10 servers or something like that, and just run the script in parallel that way. So that's all about multiple computers. The other way is single computer. So it's multi-threading, multi-processor, and multi-process. And those are very distinct things. Okay, multi-threading is when you are sharing a single processor, and that's basically it. How you actually share the processor is it's abstracted by the OS, and there's all sorts of magic included that happen. But basically, you're given threads, and it schedules it accordingly on that one single CPU. Multi-processor is if you have multiple processors. So I've got 2 processors, and I run one job on one on the other. And then finally is multi-process, which really is just, I'm using the OS to run 2 instances of something like PowerShell, okay? And then all this magic happens in the background that makes it multi-threading and multi-processor. So a lot of what we're going to be talking about is very, we're not going to dig into, developing a multi-threaded system from scratch or anything like that. All that's handled for us and abstracted by the OS. So we won't have to dig into those details too much. But this is the basic answer. This is the basic concept to it. You want to make your scripts faster by running them simultaneously somehow, or running them, aggregated out there somehow. So we'll start talking about the multiple computers. Okay, multiple computers. Who here has heard of invoke command? All right, you're at the right summit. So this PowerShell remoting, invoke commands is one of the coolest things to come out of PowerShell. In this case, we say it's good for one-time scripts because it's something that, like, if I just have something and I need to run it on a whole bunch of systems really quickly, invoke command is great for that. You can pass it a script, or you can pass it a script block, and it can run that for you. There's a couple things to note. We've scaled it. We've heard the number thrown around. We do 5,000. I've heard 5,000 to 6,000. Some people have gotten it. There's a bottleneck at the host at some point on resources when you do invoke command. Invoke command leverages this thing called fan-out remoting, if you're not familiar with it. So I pass it a list of computers, and it's going to hit all of those simultaneously, and then those sessions are going to come back. So really what your local system is doing is not much. It's just waiting for data to return. Yeah?
Not all.
Not all, but...
Throttle limit?
Yeah, there is a throttle, yeah. You can manage that a bit. Yeah. So it's not quite, but you still get the same kind of experience, and they do come back in parallel. So they come back as they finish, and then your system has to then handle it. It requires minimal changes to code, so if you have an existing script and you need to run it in parallel, generally it just works. I say minimal because there are things that won't work in a remote session. things that require like interactive sessions and those types of things. There's a bunch of little caveats and a whole bunch, which I'm sure Alexander would share every single one of them with you because he knows them all by heart. Anyway, so it requires minimal changes to code. And then the other thing to note is the double hop exists. So if you're not familiar with the double hop, put simply, if I connect to a remote computer using invoke command, I then can no longer use that credential to hit another remote system. So if I need to access like a UNC path, that's going to give me trouble unless I've configured the UNC path to sort of allow like everything. And it goes beyond that. But the point is that you can get around this if you need to. But generally, when you're talking about distributed computing, you're not going to be doing this for the most part unless you're doing some sort of jump servers and things like that. The way to get around this is to use the authentication mode of credSSP. But credSSP, you want to use it sparingly. You don't want to enable this across your entire server plant or even your desktops. That would be pretty bad. So just as a quick demo, just to show you how this works, this one will be really quick. I've got a server here. I'm not sure if you can see. It's going to be small. But basically, I'm calling this invoke command -computer name and specifying server 1, server 2, and then the script block, all I'm getting is the host name in this case. So if I execute that, you see that it's basically returning the host name from both at the same time. What's interesting is if you actually set this to a variable, one thing you do have to do when you start engineering solutions that leverage this, so in this case, I've got server 4, wasting time. So if I set this to that, okay, so I now have this t variable, and you can see that it returns the data. But if I inspect that a little bit more closely, you can see that it also has a bunch of metadata about what the computer that I ran it against was. And this is important because when you start collecting this data back using invoke command, you're going to want to be able to handle and appropriately report on which server finished and which one did what. And so generally, you wind up building some sort of set of objects that after the data comes back, you start looking at the PS computer name, which I think just shows up nowadays. Yeah, for each one of these. Okay, so that's the remoting way of distributing your stuff. I'm going to talk about one other way to distribute using something that you guys have probably all seen, PSExec, but it's debatable whether or not this should actually be even in this deck, just because PSExec is cumbersome. However, you can use it to launch distributed code. So you could use it to hit another server and run them in parallel. So that's why it's listed here. It's also listed here because it does something specific that you can't do with invoke command, and that's actually run as with the interactive session. So if you needed access to components on an interactive session for whatever reason, personally, I actually, I've got a script that enumerates, open windows and gets the IE tab associated with the PID. That wouldn't work unless I used PSExec and actually ran as that user. There's other ways to do that type of stuff too, and we'll talk about that next. PSExec, if you're not familiar, this is the sysinternals tool. When you install it, when you run it, it actually creates a service on the endpoint that gets installed and then starts, and then you hit it through that. So that's just a little bit about how it works. Okay, scheduled tasks. This is one of the greatest ways to distribute your code. I've seen whole systems built on this. Doug Fink in New York he actually did a project for a customer, and it was completely all scheduled task driven. There's other third-party tools that do this stuff. There's AutoSys, there's Jams, anything that can schedule and run code remotely on remote systems. It's a very similar thing, based off of, and you could build a whole process of distributed computing based on it. This one also it's good for interactive desktops, but only if you have the username and password, so really it's not good. I mean, nobody would use this. And it's also good, like if you want to simulate like services but use it as a script, you could use a scheduled task to basically run on startup or run when somebody logs in or something like that. I'm not going to show you a demo of scheduled tasks. I think you've seen those. That said, there's also the new PowerShell task schedule jobs. There's SCH tasks. There's the job schedule tasks. You can build anything on those systems, and they're all comparable. Okay, there's a bunch of other ones out there. I mentioned, Jams and But there's, of course, SCCM, BigFix. I'm sure everybody in this room has a long list of systems that could run code remotely on a system. And you can leverage any of those to get this sort of distributed processing. There's actually a grid one, and I meant to look it up before the talk so I could remember the reference, but there's a Windows grid application that will let you run .NET and PowerShell and VB script code. It might be worth investigating that. I didn't get a chance to play with it heavily enough in order to share it, but it was, I think it's an open source project. Something like Windows Grid or something like that. You can also build your own custom service. So rather than doing through scheduled tasks, if you want to create a service that listens or knows where things are, and you can hit that endpoint and run something. I mean, you can do all of this stuff. But the point is that in the end, what we're doing is we're distributing the load. And then in addition to that, now we're going to look at the next section, which is all about the single computer. You can actually combine the two and not only run things locally, but you can run things remotely and multi-thread and parallelize things there. So let's dig into that, because I think that's probably the more fun stuff than the remote one. Actually, before I move on from remote computing and like distributed computing, does anybody have any questions about that stuff? Okay, simple. That's good. All right, single computer. So the most basic way of getting a single computer to run parallel things, parallel scripts or whatever it is to run multiple PowerShell hosts. Okay, this is the easiest way to do it. It's really easy to add additional, I said servers, but additional processes. It's very hard to manage. You'll have windows all over the place, okay, which kind of looks cool if you take a picture of it, but otherwise it's a little ugly and difficult to manage. You generally have to build in some sort of way to aggregate this. Actually, all of the cases that we're going to be talking about, when you're talking about parallelizing, you're going to have to restructure your code to be able to do this stuff. So in many cases, not all cases, but sometimes, like, if we're talking about like the grid computing and getting data back, you have to think about how am I going to aggregate that data. In the case of multi-processes, they can't communicate with each other. So I don't have a single point of entry. So therefore, those multiple processes are going to have to either use the file system or something that they can share between each other. IPC is a very difficult beast to handle, especially when you have multiple, you're on separate processes anyway. You really can't do it. So you will need to think about how you structure your code if you want to leverage something like this so that you can record or know how things are doing. PowerShell host is really expensive. To run multiple PowerShells is not, it uses more CPU and memory than you probably would like to. So it's not always the greatest. Yeah.
So tell me, this sounds interesting. How do you solve that problem? Do people spin up SQL instances, or do they,
for which one?
So you got lots and lots of these servers out there, and they're running these processes. And how do you get them to communicate? How would you do that?
It depends on the situation. So I've done it a number of ways. Oh yeah, sorry. So the question was, how do you get these things to communicate? What is the best practice around something like this? The reality is, I think in the multi-process one, I would likely use the file system. You could actually have each of the scripts, dump a text file and have another process afterwards that aggregates that data. That's probably the easiest way to do it. It depends on what your task is, I guess, is the problem or the question. And then you build. What was that?
I just want to know what the
code kits? Nah, file system. It's not that exciting. All right, so let me just show you real quick. I'm going to switch to the NSC. It's easier to run this stuff. So I've got let me zoom this in. So I've got a script here. It's going to take a collection of computer names, and then in each one of them, it's going to get random, and it's going to sleep for a random number of time. Okay, so traditionally when you call something like this, so this is that script, I'm going to call it, I'm going to pass it a bunch of computer names. Okay, so traditionally this is a serial operation, right? So if you look, it's going to return one computer. They're all randomly coming, they're going in order, 0, 1, 2, 3, 4, the computers on the right. The amount of time it's sleeping is random. So that's the traditional way of looking at a serial sort of process. So to parallelize it with a PowerShell host, in this case, all I'm doing is I'm starting PowerShell. I'm passing a couple of arguments, no exit, just so that we can see them all open. No profile, so it doesn't look like cool dragon every time. And then the script that I actually want to pass to it, along with the computer names that I'm going to be passing. So in this case, if I run this, oops. Okay, so if I run this, you'll see it actually opened up, and the resolution's a little crazy, but it opened up a whole bunch of windows, and it executed them all in parallel. Okay, simple approach to the problem, but really hard to manage. You know, now I've got all these windows open, and you know, what succeeded, what failed, etc. I've got to deal with all of that. So that's the simple example of multi-process. Okay, that's okay, but that's not why you guys are in this room. Let's dig in a little bit deeper and look at some of the other things you can do. We can't talk about multi-thread. We can't talk about multiple processes without talking about jobs. Jobs were introduced with PowerShell 2.0. They're basically an abstracted way of doing what I just did at the command line. So when I created a whole bunch of PowerShell hosts, that's really what jobs are. They're background processes that sit there and they run in their own PowerShell.exe host, which is bad because the host is expensive. But the good thing is that it's neat for sort of ad hoc parallel. So like, rather than start up a whole new PowerShell session and load things, I can just quickly use jobs to sort of create some sort of background process that's running or doing something. Also a nice thing is that there's some control for it. So let me show you what a job, we'll do it here. Okay, so I have a command called start job, and I do, I'll just start here. So, I don't know, let's go 0 to 50, and for each one of those, we'll spit out the number, and we'll sleep for that number. Oops. Okay, so you see that there's a background job running. I could have set that to a variable, but I can also get that by doing get job here. So now I've got this job that's running. I can see that it's running. I see that it has data, so I can actually look at that data whenever I want to. We can see the current state of it by receive job. Let's just do get job, receive job. $J, thank you. So let's go back to that because it'll work. So J receive job, and I can get the status of it. It's all running in the background. But if we actually look at the process, which I'm not going to have a whole bunch of PowerShell hosts running, it did spawn a new PowerShell.exe. So if you wanted to actually implement this in a script, this is what it kind of looks like, and it gets a little ugly, but it will do the job. So here's a bit of code that grabs some registry information. Okay, so we grab a whole bunch of information, and then the meat of the job logic is this. So here I am, I'm getting the number of simultaneous jobs, and at any time, I'm going to launch a new job if we haven't reached that, and every time we're done with one, I'm going to remove a job. So this is just a bit of code that you could write if you wanted to use jobs. I'm sorry, this is the code. So I've got my get jobs. While the jobs doesn't equal 0 for each one, I'm going to check and see if it's running. If it is, then I'll once it's finished, I'll receive it, remove it, etc., etc. So you wind up building this, and I think this Carl Prosser and I were joking about the fact that everybody who plays with jobs the first time writes this code. So in this case, it's called start computer jobs, but it's essentially a very flexible script that you can pipe something to, and it would just launch multiple jobs and then throttle them and pull them back. This is all neat and whatever. I'm not going to spend a lot of time looking at this because you shouldn't either. Don't take any notes right now. This is horrible. This is a beast of a way to do this stuff. But I have to mention it because it is one of the facilities you have at your disposal for running parallel execution of PowerShell. So with that said, now let's talk about the really good stuff and the reason you're in the room. So the really cool stuff. The really cool stuff is when we get into the multi-threading, multi-processor automatically. And that's done via run spaces. Run spaces are PowerShell magic, okay? They're not documented very heavily. They're not even in Bruce Pyatt's book. So PowerShell in Action 2.0 doesn't even have a chapter, like a section on this, which is really incredible because that book has pretty much everything else. I think he refers to run spaces at one point, but it's actually in a different context. This is the most efficient way to do multi-threading with PowerShell. Okay, you get fine-grained control over, so you're going to create a run space, and your run space is going to do all that magic, and within that, it's going to, you're going to execute multiple things in their own run spaces, and you're going to parallelize your processing. You then have, for each one that you've created, you have control over that run space. You can add new stuff to it, you can remove stuff. There's a couple notes there. Because we're creating these run spaces, and then we're managing them, that's hard to manage. You have to develop code that's going to deal with those run spaces. Don't worry, you're not going to have to. There's another way to do it. That's the next one. But for now, if you just look at run spaces the way they exist, you have to manage what's coming back and what's doing those. The other thing to keep in mind, and this is really important, I'm going to show a demo of this, is run spaces will give you dirty state. So a run space will have a set of it's basically like its own session. You'll have its own variables. If you set those variables and then run more code in it later, it's going to have those variables. Okay, so you just have to keep that in mind when you're using this. There's ways to clear out memory if that's actually a concern. Like if you're running in parallel and you need to do a cleanup job, you can set your variables to null, remove them, and then run a garbage collection. It's an expensive process to do so, though. But just know that you have an out if you're running into problems where you're doing run spaces and your memory set or something is getting out of control. So let me show you a demo of how this works. It's all .NET code. Most of the time, you only see run spaces in documentation for C#, for people who want to embed a PowerShell host. Oh, the other important thing. Run spaces, the reason that we even have run spaces is it's the technology that drives the WinRM stuff. So when you connect to a WinRM endpoint, it's actually using a created run space in that place. So you're not overloading the host and creating a denial of service from a whole bunch of PowerShell.exe. Yeah.
So the run space is then leaner than the host, right?
Yes, very much so. They run in a single process, and it's just threaded.
So are you saying it's expensive to tear them down and spin it back up? Is it more efficient to clean it up?
It would be expensive to do that, but that is an option. You could do that. There's nothing to prevent you from stopping and cleaning it. As far as benchmarking that, I don't think anyone's ever done that. That would make a really good, interesting article. Comparing garbage collection versus tearing down a run space and starting it. That's whoever wants to steal that, go for it.
And by garbage collection, you mean just actually .NET garbage collection?
Yeah, it looks like this. So basically, garbage collection is this command. It's gc : there's a static method collect. So it's pretty weak if there's nothing you're removing, but if you have like 2 gigs size set of memory or whatever, and you start removing all your variables, it can be expensive. I think Oshin actually has a really cool thing in his profile that keeps a state. So basically when he logs in, he has the ability to keep the state of all variables that are system variables. So he enumerates, he has a collection script that will basically take any variable that's not one of the ones that should have started up when he created his session, and then it removes those and then runs garbage collection. It's pretty cool. Okay, so where were we? We were going to talk about the run space. Let me show the example of it. So this is what a run space looks like. Okay, I've got my code over here, which is just a script block. In this case, I'm going to sleep for 2 seconds and say hello. I create the run space by using the PowerShell type, and there's a static method called create. On that, we call an add script, and we add the code. Okay, so this gives me my PS1 variable here. We then can do a begin invoke, and we get a handle returned to us that we need to keep because you'll need to use that later. And here I'm testing for it. I'm saying while the handle is, it's not completed, just print a little dot and then sleep for 500 milliseconds. Once this is done, it's going to go on to the next section. It's going to end the invoke, and it's going to close the run space and dispose of it. So let's see what this looks like.
Is this in your slide deck?
No, but I will make this available on Git, and I'll put a link in the slide deck. I didn't think about that until you just asked. So anyway, so as you can see, this just created one. So this is single threaded. I mean, I'm not doing anything special. I'm just running one thing in its own. But I mean, you can see that I'm able to run other code while this code is running. Like it's now a background. It's running in its own space, for lack of a better way of putting it. Okay, so multiple run spaces. Is that visible?
Yep.
Okay.
Yep.
So in this case, I'm going to do the same thing, but I'm going to create 2 of them. So I've got code 1, which is going to do sleep for 4 seconds, and code 2, which is going to sleep for 2 seconds. I'm going to create 2 of these, the PS1 and PS2. And I'm also going to show you guys right now I'm looking at the number of threads on the PowerShell ISE host. So you can see exactly what's happening at the thread level. And then basically I'm going to start the script. So we're going to see how many threads, we're going to start the script, we'll see the threads jump up, and we will then run the script over and over, and instead of doing a dot this time, I'm going to keep showing you the threads. And then we sleep for 500 milliseconds and keep going. And then at the end, we're going to end both of these. And then look at the threads one last time. So we do this, we've got 2 scripts now running in parallel, and you can see the threads. Let me show you the threads again. So it's at 24 when it starts, it's up to 26, and then back down to 24. and 23 in this case. It's not exact. Like threading is, there's other things going on in the system, so it's not just like, if you start a run space, you're going to have this X amount of threads. So there's some magic that happens there. But in essence, that's what it's doing. It's using this one PowerShell ISE, it's spawning up additional threads and running your stuff in parallel. Very cool. You see the potential of that? All right, now let's get really cool. Oh, actually, hold on. Let's see if... before we get really cool, let me show you the demo of the dirty state. This is important. So in this case, I've got this code where I'm going to set a t variable in the code, and I'm saying t is set. That's all you're going to see when it runs. So I'm going to run this in its own run space. So that ran, and you can see that it returned the t is set and finished. So now I'm going to take the PS1 that I created and I ended over here, and I'm just going to add a new script to it. Okay, and this new script is going to just output the $t, so I'm going to get to see what the variable is set to right now. And I'm just going to run that again in the same run space. So I'm just doing everything again, and I'm reusing that run space that already existed. And as you can see, t comes back as the word blah, which is what we set in the run space. That's what was the first script up here, is we set it. So you have to worry about this dirtiness. I mean, just keep it in mind when you start playing with this stuff. It could burn you. Okay, let's get to the really cool one. The one that I think, in the end, it was Tobias Weltner who introduced us all to it, to his querying and quizzing the PowerShell team over and over about what the heck this was, until he suddenly made a post about it, and everybody realized this is probably the coolest thing that PowerShell has ever seen, but it's just not documented. Run space pooling. Run space pooling is the ability to do run spaces. Okay, but you don't have to think about it as much. You can set, I need 5 run spaces to be there, and I'm going to run stuff on it, and whenever I have a new thing that needs to run, it's going to see if there's an available run space. If there is, like if the last one stopped, it's going to use it. If not, it's going to wait. So once one job finishes, the next one will be taken. Okay, and then you can run a whole bunch of things in parallel. It's easier to manage because you're setting that max run spaces and forgetting about it. However, you do have less control, which is not a bad thing in this case. When I say less control, remember, in the other ones we had the variables for our run spaces, and we were able to manage those and do whatever we wanted with them. Run space pooling, that's all done for you. So, run space pooling is very simple, but I'm going to also show you an abstraction that I put together a while ago that will change your life. Like I use this all the time. This is for each parallel. And all it's doing is it's going to do the same thing as for each, but you're going to be able to set a max threads, and it's going to run everything in parallel. So everything that you want to just suddenly speed up is now faster. It uses run space pooling, so this is where I can show you exactly how run space pooling works, but it also implements it, and then I'll show you how we use it. So in this case, I have to create, I said, there's this variable that I'm going to pass into the arguments for the create run space pool, but it's basically just the session state is going to be a default one. The meat of it's here, run space factory, create run space pool is the static method. Geez, I just drew a blank on what one is. It's always one, whatever it is. I think it's the current session or the current host, I think is what it stands for, if I'm not mistaken. Oh no, that's not. That's something else. No, it's not, because you actually pass host later. We'll have to look at the documents. I'm sorry, I don't remember that. You basically say the max threads that you want. You pass it this initial state, session state, the one that we had up here, and then $host. And in PowerShell, $host, if you're not familiar with it, is the current. It's the current system I'm in. So right now, this is my PowerShell ISE. It's a bunch of objects and variables and things that you can have on it. So I'm saying that run this within the ISE that I'm, the host that I'm running right now. Okay, I then open the pool. Okay, in this case, I create a little container so that I can manage the threads and keep track of them. And then I do everything that I was doing before. So I've got a script block. I'm creating a new squad. So this is just creating a script block. So that's the actual script itself that's going to be run from the command. The only thing that changes from what we were doing earlier, so in this case I'm adding a script, I'm adding a script block, and I'm actually adding arguments to it. But the only thing that changes is now I'm setting that PS, in the last one it was a PS1 variable, a PS2 variable. In this case, you just set the property for run space pool to the pool that we created. Okay? Once you do that, the only thing I'm doing here with threads is I'm keeping track of them, because I'm going to get all those handles back, and I need to be able to close them, do things with them. So So in this case, I'm looking through. So it's going through all of them. It's keeping track of the threads as they're starting, and then it's ending them as they're done. Okay. So it goes through each of those. So how we use it and what, so that's really cool. That's all the magic that's in there. But you can actually use the abstracted version of it, which is just this. So for each parallel, lets you take. So in this example, I've got 0 to 20. I'm going to parallelize it. So I'm just going to pass it to like I would normally through for each, and I'm going to specify max threads of 4. So it's going to run only 4 at a time. And now if you see the way this works, I actually have to source for each parallel. So if you run it, you'll see that these should come back in batches of 4. So it's sleeping, it's printing the name, it's sleeping for 3 seconds, it's printing, and you see it's doing the batches of 4 all in parallel. Okay, so this is a really powerful way to just suddenly speed up all of your scripts. Now, keep in mind, we haven't talked about it, but we mentioned it when we talked about the multiple processes. But you do have to worry about CPU bottlenecks and memory bottlenecks and all of that stuff. And really, there's no magic way to do that. You have to monitor it. You could probably extend for each parallel to get really interesting, where it could calculate how much CPU is being used and try to figure that stuff out. Generally, it's better to just figure out what your max threshold is on whatever box you're using. Do a stress test, see how much you can push through it. Keep your CPU at about 80% maybe, depending on what else you're doing. Just in case your script might have bursty parts or something like that. But just you'll have to do some performance monitoring on it. Yeah.
Are you talking about parallel workflow as well?
Sort of.
Okay.
It's a footnote. We'll talk about that in a second. Let me show you the rest of this real quick though. So in this case, 0 to 50, I'm doing max threads of 4, and in this case, it's pretty much similar. In this case, I'm just getting random. I'm sleeping for random amounts of time and showing those what numbers. So you can see it's all happening in parallel. You can do stuff like, in this case, this should work. Let's see. I'm pinging. I had some mess up with my labs, so I'm not sure if I can actually connect to these. So this is pretty cool because it can actually do ping tests in parallel. So you can see here that it's actually doing the ping test and it's coming back. In this case, it's coming back one at a time, probably just due to stress on my computer. But generally, that comes back at the same time. And then finally, just an example of the dirty variables. So here I've got 0 to 10. I'm doing for each parallel with a max threads of 4. All I'm doing in my script is I'm incrementing $R, which is, it's not set to anything, so it starts as 0. I'm going to specify what number we're up to, and I'm going to show you what R is set to in each one. And so because I'm running 4 at a time, you'll see that all of them have R initialized as 0 to start. And then, so if we look at the results, they all start here. So N, again, is the number of the job that's running, and R is what R is set to. So you'll see that I have R in 0, 1, and 3. They were all using separate run spaces, and they all started 1, and they had 1. And then this one reused 1, so therefore the variable is set to 2. It's just the concept, again, is just making sure you understand that those dirty states exist, and that you can set variables, and you cannot rely on variables. Make sure you have them set to something before you move on. Any questions on this? On the one space pool? Yeah.
Did you experiment with the session state?
No, not at all. Okay. Not at all. I don't know if anybody has, and it's a great question. Use default. I don't even know what it does, to be honest, in that session state.
You can set it like both loading session state stuff, or you can target core modules automatically use certain variables, stuff like that. So then you can have, rather than having like run the script in your run space when it starts up, it'll be in that state.
Yeah. Cool.
And you can also specify that you shouldn't load the default modules if you know that you're not going to use them.
Yeah.
Those are resources that will.
Yeah. You can do that. That's interesting. I have to play with that. All right, that's good to know. If you didn't hear that, session state was all about how you get the, sort of your initial state of the session. So anything that you might want to preload, perhaps you could do it through there, or you could even not load system modules and things like that might slow down your processing. Question in the back.
Yeah, I've seen examples of passing variables between run spaces using synchronized hash tables. How do you do that with run spaces?
Synchronized hash tables.
Yeah.
Mm-hmm. So I'm sorry, that's actually foreign. The IPC in PowerShell is generally pretty bad, so I'm kind of curious how that works. As far as synchronizing the hashes, unless they're reusing the hash, so you're saying in multiple run spaces?
Yeah, I've seen examples where they do it in one run space, while they'll use a synchronized hash to pass variables back and forth.
I mean, you can always deserialize it to the file system. You could do something into memory and then pick it up later. But I don't know if anything default that does that, or anything built in. That would be really cool if it existed.
Well, what he's referring to is using a hash table. There's a static method called synchronize, and it allows you to automatically locks that table's only one director write to it at a time.
Oh.
So you really don't have to, or you don't have to do anything to support variable passing with these run spaces, because the run space itself you can return a PowerShell object right from the run space.
Yeah, but the question always comes up.
Run space pools, but in pools, if you are managing all the run spaces yourself, you do PowerShell.create and you execute something, and that script block that you execute when you add script, if it returns an object, it'll return it back to
your parent session. Yeah. No, but the question of IPC always comes up, when you talk about parallel processing, because it exists in most other languages. This ability to just take two run spaces that are completely separate and have them communicate to each other, if you ever needed to, for whatever reason. The best answer I think I've ever heard was to use. A lot of people use like TCP/IP sockets, and they just create something on 127.0.0.1 and have communication back and forth. That's some pretty advanced, crazy stuff. But you guys are here; you should know about it. Anyway, so that's run space pooling. Let me move on to the last little sort of section on. Totally forgot about this. This is why I'm here. I want to see this. Actually, I want to see a use case for it. Here's the problem. This isn't so much. This is an idea that I've had for a while around running parallel processing or asynchronous type processing. It all started because the PowerShell host is really expensive, and so if I want to run scripts, like if I want to run 20 scripts on a remote computer, it's very expensive for it to start the PowerShell host. And even my remote sessions, like I don't want to keep those sessions open, and I want it to be quick. So I developed a thing that basically would have a service queue that, if a script gets put into a file system or it gets a message from something, Zookeeper, wherever it is, it gets a script and it would execute when it gets it. So it asynchronously just pulls in whatever's coming and it just runs it. So that exists. I mean, I was able to do that as a proof of concept, but I'd love to be able to see this on multiple hosts and using something like that Zookeeper or a file system. You can create locks, you can create a whole queuing system. The problem I've always had was finding a use case for this. So not many people do sort of batch processing with PowerShell. Generally, you're doing admin type tasks or you're automating some sort of something, but nobody's developing like long-running processes with it. However, if they did, this would be really cool to see, which is basically, I've got that queuing system running on 30 machines, okay? And so all I do is say, I want to run a script out in my grid, my cloud, or whatever you want to call it. And so I put it into whatever that system is, whether it's UNCPath or Zookeeper, or whatever the latest flavor from Golang is. And basically, I see the thing in there. The service queue could create in another folder a lock directory that basically just says, okay, I'm going to try to run this script, so let me create the lock. If it gets there first and locks the file in place, it then has the right to run that. So if anybody else is trying to run it, they're going to try to lock and they're not going to be able to succeed, so therefore they won't run the script, they'll just leave it alone. When the script is done running, deletes the lock and it looks again in the queue for the next file. So it's a really clever, or it's a really simple way of doing massive amounts of distributed compute using PowerShell in a sort of, for lack of a better word, like a treadmill fashion. So you put stuff on, it gets processed, and it moves to the end. It would be really cool to see. If anybody has any use cases for that in their environment now, I'd love to hear about that. But anyway, that's basically it. The other ones, and I put workflows as other. And I purposely did that because the workflow for each parallel, to me, it never performed exactly the way I wanted it to. It also, it's gotten better. There's some tweaks that you can make to make it really a little bit more parallel. But for me, workflows, I generally don't use them. So, for me, if I wanted to parallelize something, I would rather use a run space and control it all myself and do it with script. Maybe the workspace calls that. The workflow calls that or something like that. Is anyone here using for each parallel and workflows right now?
Sure.
Yeah, I mean, mainly for asynchronous type tasks that you run out. What were you doing?
The point with workflows is not to use them just in PowerShell host, but in service management automation in Windows Azure Pack or in Azure Automation now.
Yes, so use them.
This is really the reason why they exist.
Yeah.
So
yeah, I've seen some cool
the point
demos
with
of
workflows
the Azure
is not
workflows.
they are done faster.
Yeah,
because they are made for long-running processes.
Correct.
So
if you didn't hear that, workflows are not designed to be faster. They're designed to be long-running and stable. That's what they're for. So that's why I keep it as a footnote here. The other thing is that .NET has some capabilities built into it. There's a for each parallel sample on the net from MSDN that you can implement a similar thing, but just using native .NET. The problem is that the code doesn't translate into PowerShell. It's using sugar that is not acceptable, unless you were to do it in like add type. So you could actually create the function and classes or whatever and figure a way to do that. So I note it here as something just to understand that generally the run space pooling does everything you want from this perspective, so there's no point in looking at the .NET one. And even if there was, it's very difficult to do. It would be interesting if somebody did it at some point. I'd like to see that too. And then the last one is just a little footnote on linear algebra. So if you're doing numerical calculations, chances are you shouldn't be doing, you can leverage a mathematical library for that. There's a bunch of them for .NET. So if you wanted to do, so if you're not familiar with linear algebra, it's this idea of, you've got matrices and vectors, which is a field of numbers. And if I need to change that field and do mathematical operations on them, I can do them all at once in parallel. Using some of the libraries that exist there. The only note is if you do have to do that, make sure you look at that library very closely because some of them are implemented very poorly. I think the first one that comes up on Google is actually a serial version of it. So it does the matrix math, but it actually isn't parallelizing anything, so it's not really helping you. But it's something to keep in mind if you ever are dealing with math for any reason. So that is parallel execution in Windows PowerShell. I'm open to questions, or if anybody has any other things that they think or have tried or have done, I'd love to hear if you've had success in anything else that doing something parallel. Otherwise, if you have any questions, we have a couple minutes. No? All right, how many people here have not used run space pooling before? How many people here are going to try it the first thing they do when they leave this room? All right. Like I said, I'll make the code samples available. For each parallel is actually on my blog already, but I'll put it in the deck.
So one thing I didn't mention is that a lot of commands have intrinsic capability to do parallel execution. You think about get send instance, for example.
Correct. And in many cases, it's very similar. It's actually doing what like an invoke command does. So it's taking a block of computers and it's running them in parallel. I should have actually included the sims stuff. I'm sorry about that. Yeah, because by using -computer name on the sim stuff, you can still also go out parallel, just like you do with remoting.
But not just sim commandlets, but
all the wrappers.
Sim commandlets from the sim module.
Yes.
Because they support the sim session parameters, so they can run in parallel.
Correct. Yeah. All right. Well, I hope your code gets faster. Thanks.